Hello students. In this little lecture we will see a few examples of implicit differentiation. The first example that we're going to start with is the following. Find dy dx by implicit differentiation. And the function that we're going to deal with is x squared plus xy minus y squared equals to 2. So one more time, what does it mean to use implicit differentiation? We're going to think about y as a function of x for which we can't solve or it's just too hard. Therefore, we're going to just take derivative on both sides and we'll treat y as a function of x. So we have derivative on the left side and we have derivative on the right side. So let's start with the left side. So first we need to find derivative of x squared, and we treat x as just a regular variable. Therefore, derivative of x squared is just 2x. Then we need to find derivative of x times y. You can clearly hear that it's x times y, so we have to use the product rule. Let's see, the product rule says take derivative of the first function, multiply by the derivative of the second, plus first function times the derivative of the second. We calculated the derivative of x times y, now we're going to calculate derivative of y squared. But y is not just y is a function of x. So we have function of x squared. We have to use a chain rule. For the chain rule we have to find the inner function and the outer function. If we calculate y of x, then we would need to square it. So the square is our outside function and y is our inner function. Let's apply the chain rule. Power function first. Therefore 2 goes down, then we have the original expression to the power 1, and then we need to multiply by the derivative of y. So it's going to be y prime at the end. So we're done with the left side. Now we're going to move to the right side where we're going to calculate derivative of 2, which will be 0. So let's look where we have primes. We have a prime in here, we have a prime over here, and we have a prime over here. So let's try to deal with it. We have 2x plus derivative of x is 1, so it's just y, plus x times y prime. Here we can't really calculate derivative because we don't know the function y, and we have 2y times y prime equal to 0. What are we trying to find? We're actually trying to find the derivative of y, right? Because dy dx is just another way to write y prime. Alright, so let's try to solve for y prime. This term has no y prime, so we're going to subtract it from both sides. This term has no y prime, so we're going to subtract it from both sides. And on the left side, we're going to factor y prime since it's a common factor. So on the right side, we have negative 2x and negative y because we subtracted it from both sides. On the left side, we're going to factor y prime, so we're going to be left with x minus 2y. Finally, to get y prime, we're going to divide both sides by x minus 2y. So we divide, and our final answer for y prime, or dy dx if we want to use the denotation, which is equal to negative 2x minus y divided by x minus 2y. And that concludes this exercise. This is our answer. As you can see, inside of the answer we still have y, but it is normal for the implicit differentiation, so we shouldn't worry about it too much. Alright, so second example that we're going to deal with it today is the following example. It says that find an equation of the tangent line to the curve y times sine of 2x equals x times cosine of 2y at pi over 2 and pi over 4, and that's our point on the curve. So definitely we don't have y equals to a function, and it would be too hard to solve for y over here, so we're not gonna solve for y, we're just gonna use implicit differentiation. And for the implicit differentiation we don't have to solve for y, that's the beauty of it. So implicit differentiation tells us so we're going to use implicit differentiation. Take derivative of the left side, which is y times sine of 2x, and take derivative of the right side, which says x times cosine of 2y. Derivative. So let's look at the left side first. Inside we have a product of two things, y times sine of 2x. So we're going to use the product rule first. Product rule says take derivative of y, and we can't really calculate it yet, times the sine of 2x plus y times the derivative of sine of 2x. So we use the product rule. And I'm not calculating any derivatives yet, I'm just using the product rule without any calculations. Let's look at the right side. On the right side we also have a product of two terms, x times cosine. So the product rule says take derivative of x, multiply by the cosine, add x times the derivative of cosine. So we accomplished the product rule. Now we look at the primes. We have prime over here, but this derivative we can't calculate because we don't know what function y is. So we're just going to keep it as y prime. And then sine of 2x we're going to keep since it doesn't have any primes. Then we have y. Now we have to find derivative of sine of 2x. But we can clearly see here that it's a sine of 2x, so we can't do it directly, we have to use the chain rule. Chain rule asks us to find the inner function and the outer function. We can clearly see that the last thing we would do if we would have to evaluate this, we would calculate sine, so this is the outer function, and 2x is the inner function. The chain rule tells us take derivative of outer function, which is cosine of 2x, multiply by the derivative of 2x. So we're done with the left side, we move to the right side. Derivative of x is 1, so it's 1 times cosine of 2y plus x times, and now we have to find derivative of cosine of 2y. So it's very similar to the previous sine derivative. We have to find derivative of cosine first, which is negative sine of 2y times the derivative of 2y, since I'm using the chain rule. So we go through, we have prime over here and we have prime over here. So what do we get? We get y prime sine of 2x plus y times cosine of 2x times the derivative of 2x, which is 2. On the right side we have cosine of 2y minus y minus, because we have a minus over here, so we move it up front. Then we have x, we have sine of 2y, and we have derivative of 2y. 2 is a constant, so we can move it up front. And derivative of y is derivative of y, because we can't really calculate it. We don't know what y is. So we just keep it. Finally, we have to find y prime. Why do we want to find y prime? Because our exercise asks us to find the equation of the tangent line. So we want to find y prime because y prime is the same as the slope of the curve at pi over 2 pi over 4. So let's try to solve for y prime. So this term over here has y prime and this term over here has y prime. So I will add 2x sine of 2y y prime to both sides. And this term over here doesn't have y prime, so I would like to take it and move it to the right side by subtracting it from both sides. So we're moving these two terms around. On the left side we will be left with y prime sine of 2x, which comes from here. Then we have plus 2x sine of 2y y prime, which comes from here. And then on the right side we have cosine of 2y, which comes from here. And we have this term which comes over here but with a minus sign. Alright, so with a minus sign. Let's write it, minus y cosine, and maybe move number 2 up front, so 2y cosine of 2x. So we have y prime, we factor it out, we're left with sine of 2x plus 2x sine of 2y equals to cosine of 2y minus 2y cosine of 2x. Finally, we divide both sides by sine of 2x plus 2x sine of 2y. Both sides. So on the left side we can divide, and on the right side we will get sine of 2x plus 2x sine of 2y. So finally, to find the slope, we need to take the derivative and evaluate it at the point pi over 2 pi over 4, and this is x and this is y. So let's try to do that. So we'll have cosine 2 times y, which is pi over 4, minus 2 times y, which is pi over 4, times cosine of 2 times x, which is pi over 2. So we're done with the numerator, we're moving to the denominator. In denominator we have sine of 2 times x, and x is pi over 2, plus 2 times x, which is pi over 2, times sine of 2y, and y is pi over 4. Alright, so let's simplify it a little bit before we move to the next line. 2 and 4 we can divide, so we're gonna get 2. 2 and 4 we can divide, so we're gonna get 2. This 2 and 2 we just can divide. Divide, 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 and divide. Then 2 and 4 gives us 2. We're left with cosine of pi over 2 minus pi over 2 times cosine of pi And in the denominator we have sine of pi plus pi times sine of pi over 2. So now let's try to remember things. Cosine of pi over 2 is actually 0, and cosine of pi is -1. And we know that sine of pi is 0, and sine of pi over 2 is 1. So finally we have minus pi over 2 times -1 divided by pi times 1. And pi, we can think of pi as pi over 1. So in the numerator we have minus and minus, which is plus, divided by pi over 1 is multiplying by 1 over pi. So we divide, we get 1/2. Finally, the equation would be y minus y value was pi over 4 equals 1/2 times x minus pi over 2. Pi over 2. Alright, so we used point slope equation of the line. And if we distribute 1/2 through the expression, our answer on the right side will be 1/2 x minus pi over 4. So we have y minus pi over 4 equals to 1/2 x minus pi over 4. So if we add pi over 4 to both sides, they're gonna disappear. So finally our answer is y equals 1/2 x, and that would be our final answer. So in this little lecture we did 2 examples of implicit differentiation. Now it's your turn to practice with the homework, and I will see you in the next video lecture.